Alrighty, so here are two problems, two piecewise functions. This first one is the one we did in class, so I'm going to do it again just to make sure everybody's got it. So when you graph a piecewise function, the first step, I got to get a marker, sorry. First step is going to be to plot your boundary points. So I'm going to write those steps down. So step one, plot boundary points. That will really help. And what I mean by boundary points is, remember a piecewise function, you have f of x, and this piecewise function has three pieces to it, negative x, x squared, and 1. Each one of those pieces has boundaries. This first boundary is x is less than 1, so that 1 is the boundary. This next piece has the domain negative 1 less than or equal to x less than 1, so it has two boundaries, negative 1 and 1. And this third piece has this as a domain, and its boundary is 1. So the boundaries are what are used to tell you what x can and can't be. So I'm going to plot the boundary points. So the way you do that is you take each one of the boundaries and you plug it into that function that it goes with. So this first boundary right here, the 1, I'll plug it into negative x. So if I put a 1 into negative x, I'm going to get a negative 1. So, oh, that's supposed to be, I made a mistake there. It's supposed to be a negative 1. So sorry about that. So you put a negative 1 into it. So if I put negative 1 into this function, the opposite of negative 1 is positive 1, so I'm going to put an open circle there. And the reason it's open is because it's a less than. So there's your first boundary point. You're going to have to decide if these are open or closed. The next one, I'm going to put, for this one, I'm going to put negative 1 into this function now. Negative 1 squared is 1 also, and that one is closed because of the equal to, so that it overlaps on this open point and it fills in that hole. That point covers up that open circle. Then we come over to 1, plug that in. So we got 1 squared is 1. And that will also be a closed point. Okay? And then we go to this last one right here, 1. Well, this is a horizontal line at 1. So when you got f of x equals 1, and you plug 1 into it, no matter what you plug in for x, the y value always equals 1. So that's just going to be 1, 1 also. And it's already closed there. You can't open a closed door because the door is locked. So just remember, points are always closed. They don't unlock and open up. So these are, yeah, closed points never open. All right, so then we plot. Second step is to just plot, is to graph each function. Graph each function using domain restriction. So plot each function using domain restriction. So you're going to have a domain restriction. So the first domain restriction is x is less than negative 1. So I want to plot the line, this line here with a slope of negative 1, and I want to be less than negative 1. So if this is negative 1, I want to be less than that, and so I want to go to the left. This means go to the left of negative 1. So how can I graph a line? I have a point. You need two things to graph a line, a point and a slope. The slope is negative 1. So how can I go to the left? I can't go down 1, right 1, because that wouldn't take me to the left. So I'm going to have to go up 1, left 1. I have to go up 1, left 1, and once I get another point, then I can graph that line. So there it is. And that's to the left of negative 1. Now when I plot this parabola, I'm going to go to these 2 points, the negative 1 and the 1, and I'm going to connect them. But I'm not connecting a straight line. I'm connecting a parabola. And I know the parabola is centered at 0, 0. I'm going to do like this. And then this last piece is a horizontal line at 1 when x is greater than 1, so I'm going to go to the right of 1. So I'm going to graph a horizontal line to the right of 1. So there's that first piecewise function. Really pretty straightforward. So plot the boundary points, graph each function using the domain restriction. So let's try that for this next one. I'll erase this and move my directions over there so you can see it. So I still got my directions here. So let's try it. So you got 4 pieces to this piecewise function. 4 pieces. All right, so I'm going to start by plotting this boundary point first, negative 2. So I'm going to plug it in. So what's 1/2 times negative 2? That's a negative 1. And then negative 1 minus 1 is a negative 2. So I'm going to have the point negative 2, and it is open. Why is it open? Because I have a less than. Okay, now I'm going to plot the next boundary points. So I got a negative 2 and a 0. So let's plug -2 in first. -2 minus 5 is -7. So I'm going to be -2, -7. So -3, -4, -5, -6, -7. So I'm going to be way down here, and that one is closed. And these are piecewise functions, so when you're done, they better pass the vertical line test. And it'll pass the vertical line test at -2 because if you imagine a vertical line there, it only intersects here because the open circle is not included. Okay? Then I'm going to put in 0. 0 minus 5 is -5, so 0, -5 will be down 5 on the y-axis, and that's closed as well. Now we go to the next function, 0, 2. So I'm going to plug 0 in. 0 squared is 0, so that's going to be open. It's an open circle. Plug in 2. 2 squared is 4. 1, 2, 1, 2, 3, 4. That one's also open. So I'm just getting all these points plotted. And then 2, 4. That's just remember this is just a horizontal line at 4, so 2, 4. It'll be 2, 4, and that closes that point actually. So the close always trumps the open. So just think of like cards, it's a trump. And if you want to plot the boundary points and graph the functions as you go, sometimes it's easier to keep up with where your points were. Like I remember that this one, -2 was the open one, so that's how I keep up with it, was it the open one or the closed one. So I'm going to go to this point. I'm going to graph the slope, which is 1/2. I can't go up 1, right 2. Okay? I need to go down 1. So I'm going to go down 1, left 2. So I'll go down 1 and I'm going to go left 2. So I'm going to say down 1, left 2. That'll put me right here. And I can draw that line. Now, if you imagine the slope is 1/2, and if you can kind of project to the right, imagine what it would be. If you went up 1, right 2, you would hit the y-axis at -1, which agrees with your y-intercept, so you know you did it right. Even though I'm not going to draw that, because I only want to be to the left of -2. Okay, and then the next part right here is the line x minus 5. And the line x minus 5, it's a line. You have 2 points. You have 2 closed points. You just got to connect the dots. It's a line. Or you can go up 1, right 1, up 1, right 1. The next part's a parabola. So I'm just going to draw a parabola-looking curve from those 2 points there. And then it's a horizontal line after 2, because to the right of 2, and there's that piecewise function. So that's how you do it. Thanks for my audience, too, that was here. Special guests, Gretchen. No, not Gretchen. Heidi Weber and David Reyes. So